Hello everyone and welcome to the presentation of the automatic room light controller simulation. Before running the simulation, I will go ahead and introduce you with the different components involved in the schematic. Right here we have the microcontroller, which is a PIC16 F84A microcontroller used to program in assembly language the different functions of our circuits. Above here it's the motor driver controller, which basically controls the two DC motors, which are here to represent the motors attached to the door to actually simulate the motion of the door to see that it's actually opening or closing. These two components are the BCD to decimal converter integrated circuits, which are used to take the output from the microcontroller and write out the signals to the 7-segment display depending on the input given by the microcontroller. And down here it's a serial to parallel integrated circuit. This was used because the PIC16 F84A has a limited number of output and input pins, and given that we were using a lot of output pins, we figured out that we could use a serial to parallel to pass the information concerning the 7-segment display. And here it's the bulb lamp of the room that we're trying to control depending on the status of these two switches, which represents they are here to simulate the effect of the infrared sensors. So I'll go ahead and start the simulation. At the beginning we can see that the light is turned off, the count is down to 0, indicating that there is no one in the room, and the door is closed. Now this first sensor, the infrared sensor, is placed outside of the room in front of the door, and then this one is placed inside the room in front of the door also. So like if someone is getting in the room, he will cut this sensor and then cut the second one after, and then if someone is getting out of the room, he will first of all cut the first sensor before cutting the second sensor before cutting the first one. So we will go ahead and simulate the first movement. Supposing that someone is coming in the room, he will cut the first sensor, allowing the door to open. You can see the motors moving, opening the door to a certain level, and then once you cut the second sensor, you can see that now we see that someone has actually entered the room. So the bulb lights up, the count goes up to 1, and then the door is now closing back. And we can keep going on, assuming that more people are coming into the room, implementing the same move, cutting the first switch, it opens the door, cutting the second switch, considering that someone is actually moving into the room. Light the bulb is still lighting, increments the count to 2, and then open and closes the door accordingly. Now assuming that someone is getting out of the room, it will first of all cut the second switch before cutting the first one. So cutting this sensor, this first switch. Assuming that there's still one person in the room and that person decide to go out of the room at one point, you will go through the same process, which is cutting the second switch before cutting the first one. Cutting the second switch, we can see that the doors are actually opening, and then after cutting the first switch, now the count is decremented to 0. The bulb went off, and then the door is now closing. Now this is actually the code running in the background of the project. At the beginning, we're basically instantiating the different variables that we're going to use throughout our systems, giving them locations in our memory, and then after defining the ports and how we want to use them, and then also now it goes through defining the serial to parallel integrated circuits that we have attached to our circuits. And then now it goes on with the different functionalities of the circuits, setting up the different ports, which port is defined as an input port, which one is defined as an output port, and then also we can actually set up different specific bits of a port to be either input or output. And then now it goes through the different subroutines, which are called depending on the state of the inputs.